All right, today we're going to unpack two words you probably hear all the time, power and efficiency. And you might think, yeah, I know what those mean. But, in the world of physics, they tell a really surprising story about how everything works, from our cars to our phones. So let's get right into it.
So, let me ask you, when you hear that word powerful, what's the first thing that pops into your head? A super fast car, maybe? A massive engine? A political leader? I mean, we use this word constantly, right? But what does it actually mean when we're talking about science?
Okay, so this is where it gets really interesting. In our everyday conversations, power usually means something like strength or maybe influence. But in physics, the definition hinges on one single crucial word: speed. It's not just about what you can do, it's all about how fast you can do it.
So, let's really dig into that physics definition. What does it actually mean to measure the rate at which work gets done? Let's unpack that. All right, here's the official, by-the-book definition. Power is the rate at which work is done or energy is transferred. Now, a great way to think about this is, imagine two people lifting the exact same heavy box onto a high shelf. One person takes their time, the other one does it in half the time. They both did the same work, but the person who did it faster, they're the one who's demonstrating more power. See? It all comes back to speed.
And of course, we have a way to measure this. The unit we use is one you've definitely heard of: the watt. Yep, it's named after the inventor, James Watt.
So what exactly is a watt?
Well, it's really simple. 1 watt is just 1 joule of energy being used or transferred every single second. Think of it like water in a pipe. The joules are like the total amount of water, the volume. But the watts, that's the flow rate, how fast that water is rushing through the pipe.
Okay, I know this can all feel a little abstract, so let's bring it down to earth with a real-world example. We're actually going to calculate the power of a motor, just to see how all these numbers fit together in practice. So picture this. You've got a motor, and it's lifting a pretty heavy object. Let's say 100 kilogram mass. We know it's lifting at 5 meters high, and, this is the critical part, it does the whole job in just 4 seconds. The big question is, just how powerful is this motor?
Don't worry, we can figure this out in just 2 simple steps. First, we need to find out how much work it takes to lift that object. Then, we'll bring in the time factor to calculate the actual power.
All right, so for step 1, we've got to figure out the total energy it takes just to lift that mass against gravity. The formula for that is mass times gravity times height. So we plug in our numbers, 100 kilograms times 9.8 for gravity times 5 meters, and that gives us 4,900 joules. That's our work done.
Okay, now for the important part, step 2. We take that total work we just calculated, the 4,900 joules, and we divide it by how long it took, which was 4 seconds. And what do we get? We get 1225 joules per second. And remember what a joule per second is? It's just a watt. So there's our answer. The motor's power is 1,225 watts.
So a higher wattage means more power. Case closed, right? Bigger is always better. Well, not so fast. It turns out that high power is really only half of the story when it comes to performance.
To really get the full picture, we have to bring in our second major concept. See, it's not just about how fast you use energy, it's about how well you use it. And for that, we need to talk about efficiency.
So, the formal definition is this. Efficiency, which, by the way, is often represented by the Greek letter eta, is just a ratio. It's simply how much useful work you got out of a system compared to the total amount of energy you had to put into it in the first place.
To put it another way, efficiency isn't about speed. It's about how effectively a system converts energy from one form to another. Really, it's a measure of how much you're not wasting.
Let's do another quick calculation, this time for efficiency, because this is going to help us answer a really important question. In pretty much any system in the real world, if some energy is lost, where does it actually go?
Okay, so let's say we have an electric motor. It's pulling 1,200 watts of electrical power from the wall socket. But when we measure the actual mechanical power it's producing to, turn a shaft and do something useful, it's only 900 watts. So wait a minute, where did that missing 300 watts just disappear to?
Well, calculating the efficiency is super easy. You just divide the useful power that came out by the total power you put in. So 900 watts divided by 1,200 watts, that gives us 0.75. Or, as we usually say it, 75%.
So what does that 75% efficiency really mean in the real world?
It means that only 3/4 of the electricity we fed the motor actually turned into useful spinning motion. The other 25%? That was just lost. It was wasted. And where did it go? Well, think about it. Motors get hot, right? And they make noise. That heat and that sound, that's the wasted energy, literally bleeding out of the system.
Okay, so now we have our two main characters on the stage. We have power, which is all about speed, and we have efficiency, which is all about not being wasteful. Let's bring them together and see why you absolutely can't understand true performance without looking at both.
Let's just break this down one last time, nice and simple. Power asks the question, how fast can you use energy? Efficiency asks, how well do you use that energy? Power is a rate measured in watts. Efficiency is a ratio, a percentage. At the end of the day, power is all about raw capability, and efficiency is about smart performance and cutting down on waste.
And really, this is the key takeaway. I mean, what good is a ridiculously powerful engine if, say, 90% of the energy it uses is just lost as heat? It's not really an engine at that point. It's just a very fast, very expensive space heater. But on the flip side, a system that's incredibly efficient can take just a tiny bit of power and make it go a very long way.
And this all brings us to a really big question, especially for our future. As we're designing the next generation of technology, what should we focus on more? The race for almost limitless sources of power, or the challenge of achieving perfect, 100% efficiency, where absolutely nothing is wasted? It's definitely something to think about.